This video focuses on the hex table and how binary, hex, and decimal relates to each other. Now, on the hex table, you will have decimal, binary, and hex. Now, one thing that you really need to remember about this table is that all of them start with 0. Now remember, decimal, your options are 0 through 9. Binary, you only have 0 or 1. And hex, you do 0 through 9 and A through F. So they all start with 0. Then we know that hex is base 16. So you want 16 numbers going down this way. And that basically determines how many lines you're going to have in your table. Now remember 0 through 9, but then we also have A through F. All of that would be 16 options, different characters, representations of hex. Okay, now knowing that when you look at decimals, 0, if you were to convert 0 to binary 0, well, you don't need 1, 2, 4, or 8, because all of those, if you don't need any of those, then they're all zeros. So that's why you have all zeros here. And the same thing with hex. 0 in decimal is 0 in hex, and so is binary. So that really is a baseline of how the hex table works. Okay, so next, the next simple thing to look at would be the decimal, because you know that we count. We can start with 0. You always want to remember to start with 0 because that's very important when it comes to networking and numbers. So always start with 0. And remember, we start with 0 and we only have 0 through 9 to work with. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So now we've met number 9 here. That's as far as we can go. So in decimal, what comes next? Well, 10, 11, 12, 13, 14, and 15. Now, remember that hex is 16. Well, why does this end at 15? Well, the reason for that is because we're counting from 1 through 15, but then we also have to count the 0, and that is a total of 16 for the hex. So basically 15 in decimal is F in hex. And to convert from decimal to hex, or from hex to decimal, you want to go through binary first. So if you wanted to know, and actually, if you really think about it, well, converting decimal to hex is very easy because it just goes down the rows. 1 is 1, 2 is 2, 3 is 3, all the way down to 9. Then it gets a bit more challenging because now we're looking at A, B, C, D, E, and F. Of course, it might be easy for you to just kind of remember, or maybe once you get more familiar with the hex table, then you'll just kind of be able to say, okay, well, I know 10 is A, 11 is B, 12 is C, 13 is D, 14 and 15. So eventually you might get used to what the numbers represent. But for now, we first want to convert from decimal to binary and then to hex. So how do we convert decimal to binary? Well, I started it over here. We do our conversion, but another thing I want to make sure that you know is that when you're converting to hex, you only need 4 bits. You only need those last 4 bits. So we already did 0 in binary. So now let's convert this 1 to binary. So this is 0. Now if you want to convert 1 to binary, just like we've done before, you can't use 8, you can't use 4, you can't use 2, and you can't use 1. Or, I'm sorry, you can use 1. So it's 0, 0, 0. You can subtract 1. So there's your 1. 2. How do you convert that to binary? Well, 0, 0, because you can't use 8 or 4, but you can use 2. So we'll put a 1 there, and then a 0, because 2 minus 2 would be 0. So we don't need a 1. Okay, let's do a little bit more work on number 3. If you're going to convert 3 decimal to binary, because now we're doing 3, we can't subtract 8, we can't subtract 4, but we can subtract 2. That leaves you with 1. So since we can subtract 2, we put a 1 there. We can subtract 1, so we put a 1 there. And now we end up with 0. Okay, and now let's do 4. Okay, you can't subtract 8, but you can subtract 4. So you subtract 4 here, you have 0, so then you just 0 the rest out. Okay, and that's basically, that is your binary part of this table. We have all zeros here, then we have 0, 0, 0, 1, then 0, 0, 1, 0 is 2, and then to put 3, it's 0, 0, 1, 1, that equals 3, and for 4, it's 0, 1, 0, 0, and you just go down the line converting the decimal to binary, and that would be the hex. Now the more challenging part would be, okay, what about when we get up to 10? Well, the same situation here. You have 10. You can subtract 8, so we want a 1 here. We have 2 left over, so we can't subtract 4, but we can subtract 2, so we put a 1 there. We end up with 0. So now it's 1, 0, 1, 0. Okay, let's do 13 now. Okay, so 13. We can subtract 8. So what is 13 minus 8? That would be 5. Can you subtract 4? Yes, you can. So we'll put another 1. That ends up with 1. Then you put a, you can subtract 2. So we put a 0 here. You can subtract 1. So you put a 1 there. You subtract the 1, and now we have 0. Okay, so 13 is 1, 1, 0, 1. Okay, let's go ahead and try the very last one. 15. Number 1, 2, 4, 8. 15, we can subtract 8. That leaves you at 7. So we put a 1 here. We can subtract 4, so we put a 1 here. We have 3 left. You can subtract 2. We have 1 left. So then you have the 1 left, and you subtract that to get 0. So that means that 15 in binary is F in hex. And notice how we started with all zeros at the very top, and then we ended with all ones. So now the question is, well, when we're doing networking, we are actually using not just 4 bits, we're using first, we're using 1, 2, 4, 8, but we're also using 16, 32, 64, and 128. So how does that come into using hex? Because there are different ways of representing things in networking. Not really in IPv4, but when you're working with IPv6, then we start using hex numbers or hex characters. So we will have 4 and 4, but then the question is, well, if we have 4 and 4, how does that convert to hex? Okay, so let's say that we have a number like, let's do 64 first. So if we want 64 in hex, what do? Well, we change that to binary. So then we can't subtract 128, but we can subtract 64. You end up with 0. So that means that everything else is zeroed out. So then you would divide that in half, and then you just convert these 4 bits into hex. So what is 0100? Well, that is 4. So we put 4 here. Then we look at the last 4 bits. Now that's all zeros. So that means that in hex it is 0. So 4 and then 0. But then the question is, how do we know that this is not just 40 in decimal? Well, there are many ways of representing it, but for now, you can just say 40 hex. Okay, now let's convert something a bit more, a higher number. So let's go ahead and do 130. So how do we convert 130 to hex? Well, the same situation, we're going to convert 130 into binary, then into binary like this, and then we convert it to hex like this. So 130, can you subtract 128? Yes, you can. So we're going to put a 1 here, and actually let me go ahead and put the numbers here so that it's more straightforward. So yes, we have 128. We're going to subtract that, and we have 2 left over. So that means that we can't use 64, we can't use 32, 16, 8, 4, but we can use this 2 here. So we'll subtract 2. Our result is 0, so we put a 0 at the end. So then the question is, what is 1000 in hex? Well, this one, if remember, now we're halving it. So that means that we're only going to use 4 characters. So what is 1000 if we're only looking at 4 different binary characters? Well, if we go back and say, okay, we're going to delete these, and we're going to just do 1, 2, 4, and 8, well, having a 1 here and nothing for 4, 2, or 1 means that the hex is 8. Then we're going to look at the last 4, and well, we don't have an 8, 4, we have a 2, and then a 1. So then 130 is 82 hex. Okay, now let's try a number just a little bit higher than what we've been looking at already. Let's look at 145. So we are going to change 145 in decimal into hex. Okay, so how do we do that? The first step is to change it to binary. So we're going to move it to binary, then we're going to move it to hex. So what is 145, the entire number, but in binary? So let's go ahead and use this chart up on top here, because we want the entire 8 bits. Okay, so 145, can we use 128? Yes, we can. So what is 145 minus 128? Okay, so 145 minus 128 is 17. So then we don't need 64. We don't need 32. That's too high. 16. Yes, we can use 16. So then we subtract that. We have a 1 at the end. So we can't use 8, 4, 2, but we can use 1. So we subtract 1 here, and then we end up with 0. Okay, now that we have the entire 145 in binary, now we want to divide it in 2 so that we have just 4 digits like we have in our binary table. So let's go ahead and delete these top numbers here. We're going to put 1, 2, 4, 8. So we use an 8 and we use a 1. So the number is 9. And that's 9 in hex. And then we only have a 1 here. So it's 1 in hex. So then we just write 9, 1 hex. Okay, let's do one more example here. And I want to go ahead and do 143. It'll be a little bit different for you. So we have 143. Okay, 143, and of course we need to go back to using our all 8 numbers. Okay, so what is 143 minus 128? Because we can use that. Okay, 143 minus 128 is 15. So can we subtract 64? No, we cannot. Can we subtract 32 from 15? No, we cannot. 16 is too high, but we can subtract 8. That gives you 7. Can we subtract 4? Yes, we can. That leaves 3. Can we subtract 2? Yes, we can. That leaves 1. And there's your last one to give you 0. Okay, so now we want to go ahead and look at it using the binary numbers again. So basically dividing these numbers into 2 different numbers, 1, 2, 4, and 8. So again, we do have a 1 under the 8. So these 4 digits is 8 in hex. Then if we have 1, 1, 1, 1, that is 8, 10, 14, 15. And if you look at the hex chart, 15 is all ones, and that would give you an F. So then that means that 143 in hex is 8F. Makes sense? And let's just say, let me just throw in the example of saying, if it was switched, if it started with 4 ones and then 1, 0, 0, 0, then that binary would be F8 in hex. Makes sense? I hope that helps. Thank you for watching.